We're going to be starting Chapter 8 now. And believe it or not, this first section is not that easy, so it's going to be kind of difficult to go through and understand fully, and also like include some word problems with it, but we're going to try the best we can. I'm going to start up with the warm-up, because that will also lead into some of the problems we're going to be doing in the word problems that we'll be doing, like in the first example. Okay, so the warm-up says, suppose you wanted to buy a pair of shoes at the mall, but they were $120. So you decide to wait until they go on sale. The next week you see a sign in the store that everything is 25% off. You only have $80 in your wallet. Do you have enough money to buy the shoes? And then we'll say there's no sales tax. Okay. So one way you might think about doing this is, first off, we have 25%. We're going to change this to a decimal. Move it over 2 times. So we're looking at the decimal 0.25. And if we have shoes that cost $120, hopefully you would maybe think that if you take 120 times the 0.25, this should represent what? That would be how much money you would get as a discount. So what would that be? 120 times 0.25. That would be $30. So this is your discount. How much you're getting off. So you would take this amount, hopefully you'd understand, take that amount, and we're going to subtract that from the original price and get $90. So then we can answer the question, do you have enough money to buy the shoes if we only have $80? So no, we do not. We need an extra $10. I want to show you another way to do this that I think is faster. So instead of making this a two-step problem, I'm going to instead just do it in one step, basically. It's just a little bit different. Instead of using 25%, saying that's how much money we get off, I'm going to use how much money or what percentage we're actually paying for. And the way you do that is I would probably just do this part in your head. I would take 100% minus 25%. Right, these are percentages. And you would realize, okay, I'm actually paying 75% for the item, in this case, shoes. So instead of going through these two steps here, I would just do this part in my head and say, okay, I'm spending 75% on the item. And if you take 120 times the 0.75, don't forget to move over the decimal over twice, then we have the $90. And that's your answer. So this method kind of gives you the price right up front. And yes, I guess you do kind of still do two steps, but I think this is a little bit easier to go through than kind of using the calculator maybe twice in this case, which could be more difficult. So you just have to take the 100% you're paying for minus the discount that we're getting off, and then use this as your percentage, 75%. Okay, so let's go to number 2. If you get a 5% discount for using your red card at Target, what percent do you actually pay for? So if we get 5% off out of the 100% you're paying for the item, right? These are percentages. You're actually paying for 95% of it. Okay, knowing that, let's apply that to this next question. If you bought a $140 Bluetooth speaker from Target using the red card, how much does it cost after the discount? So our discount was 5%. We know it means we're paying for 95% for it. So we're going to take 140 times 0.95. And that will tell you the actual cost of the speaker after the discount, which in this case happens to be $133. So I like doing that, instead of the two ways of like multiplying by your discount and then subtracting it from the total. I think this is a little easier. It takes up less steps, I think. Especially you can do some of that in your head a little bit too. Okay, so now for the lesson, 8.1. This is called composition of functions. How do I combine functions using something called composition? Okay, here's a word problem that we're going to go through, and then eventually we'll talk about composition of functions and go back to this. The Lee Munz car dealership offers 2 incentives to buy cars. Suppose you want to buy a new car that costs $33,000. They give you a 12% discount off the $33,000 sticker price of a new car. So that's pretty important. 12% is a good amount of money on $33,000. As well as a $2,000 rebate for the end of the year clearance. A rebate is just basically they're giving you money back, right? Like you pay it up front and they're going to give that money to you back. So you're actually getting $2,000 off the car. If you were given a choice, which incentive would you take first? So the question is, are you going to do the discount and then do the rebate, or do the rebate and then the discount? So we're going to work through that in these 3 steps. So first we're going to take the discount and then apply the rebate. So remember, 12% discount means you're actually paying, if you do 100 minus 12, means you're actually paying 88% of the selling price. How much would you pay for the car if you took the discount first? So let's do the discount. We take $33,000 times 0.88. So you just use a calculator for that, which I had to put in as well. So the discount, the new price is going to be $29,040. Okay, so this is if we did discount. This is the discount. Now we're going to apply the rebate. So rebate is next. So the price of the car is now down to $29,040. We're going to take that. Oops, $29,040. And subtract that by a rebate, which is $2,000. And is that easy enough to do? You would end up getting $27,040. So that is if we did discount then rebate. It would cost us $27,040. Now we're going to see what happens if we do the opposite. So we're going to take the rebate first. So we're going to take the $33,000. And we're going to subtract the $2,000, right? This is our rebate. That would give us $31,000. And then we're going to apply the discount. So the discount is $31,000 times our percentage that we're paying for, 88%. So if we do 31,000 times 0.88, we end up getting 27,280. And this is our discount. So there's rebate and then discount. So clearly, well, one, it matters which one you would choose, right? It's not just going to come out to be the same. And most likely this won't come out to be the same like ever. So which one should you choose is probably something you should figure out yourself, right? We pay $27,040 here, pay $27,280 here, significantly more money, right? So which method would give you the lower price for the car, and how much money would you save over the other option? So clearly, doing rebate than discount is better. Or I'm sorry, discount and the rebate is better. So which one's better? Discount, then rebate. How much money are we saving? Well, if we subtract those two, how much are we saving? That'd be $240, I think. And that'd be in savings. So it's a decent amount just to make a choice between these two things. Now we get to the next question of, does it matter which one you take first if the car costs differently? So does this better method, which we said was discount then rebate, is that always the better choice? Does it matter how much the car costs, which we said was $33,000 in the last example? That's a yes or no question, and why, and you're going to write your prediction here, which I'm not going to fill out. We'll talk about it later. So one way in order to do these kind of problems is called composition of function. which we could have done back here. We just don't know how to do it. Instead, we just took it step by step and just did, one thing at a time. So we're going to go through the math terminology of this first, and then we'll do some problems, and then we'll go back to the other problem of the car dealership. Because this stuff is the hard part. Definitely very difficult to grasp and understand. So definition of composite. The composite of two functions f and g, which could be written like this. It's g with like a little circle and an f. The way you read that is the composite f followed by g. Is the function that maps x onto this weird thing. We got double set of parentheses here. One thing we should probably go over is, well, what if we only had one of these? Like, so what if we had something like this? And how you read that, it's been a while since we've seen it, but the way you read that is g of x. That's how you read it. G of x. Okay? So when you go down here to this new one, how do you read this? Kind of the parenthesis set is the of word. So you read that as, fill in the blanks as we go, g of, right? The word of is like right here, of f. And what goes next? There's no set of parentheses. Of again. So the way to read this is g of f of x. G of f of x. The way to read this is way harder, to say that the composite f followed by g, which, by the way, they're saying the f first, which is at the end. Seems kind of weird, right? That will become more apparent what that means a little bit later. All right, so just to remember, the ways to write the composite function, which is the way you say this, is f composite of followed by g. The composite of f followed by g. Down here, you could also write it like this, right? It's the same thing. Actually, these two are the same thing. It's also the same thing as if you wrote it like this, which we already had up there, right? G of f of x. These two are the same, whether you write it like this or this. I much prefer using this. It's a lot easier to go through the problem that way, so I'll probably convert things from this to this. Then we'll show you how to solve them. The way you work with this, when you simplify these, you simplify composite functions by working from the inside, which is probably why they said the letter f down here first. We work from the inside with the f of x, and then we work our way to the outside. What this is essentially going to be is just substitution. If you know how to substitute, you're okay. So we've done problems like this before. Let me just give you an example where we have an equation. Let's just say it's like, 2x plus 3. Let's make something up. We've done problems where we said, okay, try to find g of 6, right? Which basically means instead of putting an x in there, you change it to 6. Just like over here, you would change it to 6. So just real quick, when you're solving this, you would just put 6 in for x. So it'd be 2 times 6 plus 3. So you would say that g of 6 equals 12 plus 3, right? That'd be 15. Okay, so just substitution. Well, we're going to do that twice. We're going to do it inside with the f of x, get an answer, then do it with the g of x that's inside here. So we're going to jump around. We're going to go all the way to the end with mastery. Yes, the very last question on the last page, number 2. We're given two functions. F of x is 2x to the third. G of x is 6x minus 4. Evaluate the expression. We're going to start with D. It's already written out for you in the right way. I like this method much better than something like B, which we're going to change into this down here. So how do you do that? Again, we're going to start with the inside. So we're going to take the 5 that is inside of the f function. And we're going to put 5 in over here. Instead of it being x here, we're going to put it 5 there. So that's what they did. They put the 5 here, which is telling us that we have to put a 5 here. In for the x. Come on. In for the x. So inside of this, we're going to leave it as g of, give myself some space. This gets replaced with what it's equal to, 2x to the third. So it's 2, not x to the third, but 2 times 5 to the third. And then you evaluate what's inside. So we can do that. The g of whatever, we need to get a number there first. So this would be 5 to the third times 2, right? So we have to do 5 to the third first, which happens to be 2 times 125. And we go a little further. We multiply the 2 times the 125 and get 250. And now, what do? We're going to apply the g function now with the 250. So now we have to go to the other function, which is up here, g of x. And instead of plugging in x, we're going to use the number 250. So 250 will be what goes here and here. So instead of writing anything else here, it's like we're just plugging in 250 over here and 250 on the right-hand side. So this is going to equal, we're using the g function now, it goes away, equals 6 times x, which we know to be 250, minus 4. And then once we evaluate this, we'll have our answer. So 6 times 250 is 1,500 minus 4. So it's 1,496. Whoops. $14.96. So we can say from the very beginning that g of f of 5 is equal to just a number, 1496. I would highly recommend you go through and do part B, which I'll set up for you to make sure you know how to do it. This one here I'll set up first. If you see this symbol, it just means the same thing as this one over here. So I'm going to rewrite it as f of g of negative 3. Try to make the outside ones a little bit bigger, set of parentheses, and the inside one's a little bit smaller. That way they're not the same size. So how do you do this? You plug in negative 3 into the g function, because now we're doing g first. They can switch around. So negative 3 goes in for g, which is this one here, right there. So I'm going to keep the f out there, put a blank spot. It's going to be 6 times negative 3 minus 4 is what we're solving first. Once we get a number out of this, then we'll apply the f function. But right now, we're keeping f. 6 times negative 3, that is negative 18 minus 4. So we get f of negative 22. Now we're going to apply the f function, because we haven't done that yet. Let me get rid of this stuff. I don't need this anymore. Plugging in different numbers. Then you plug in negative 22 in for the f of x function on the right. So the f goes away. It's all gone. It becomes 2 times negative 22 to the third. Although that seems like a really big number, and it will be. So negative 22 to the third I got negative 10,000. So 2 times negative 10,000, 648. Alrighty, times that by 2. So it's negative 21,296. That's your answer. So from the very beginning, you could say f of g of negative 3 is a number negative 21,296. Okay, so now we're going to switch gears a little bit, and we're not going to do numbers anymore. We're going to do it with just the x in there. So we're not going to get like a number inside here. We're going to have it just as the function. This is where it gets a lot worse and a little bit more difficult to understand. First step's not too bad. So what we're going to do is look at part A. So we're going to do f of g of x. So f of g of x, we don't have a number there, so we're not plugging anything in. We're just going to take the g of x that's over here and take what it's equal to, this whole thing, and we're going to plug it in inside here. So we're going to take this out, pretend taking this out, and inside we're going to include this now. It's going to be 6x minus 4. That's usually not too bad. Next step is where it gets weird. So we've just substituted in, took out g of x, put in 6x minus 4. Now we're going to apply the f function. So instead of using x here and here, we're going to plug in 6x minus 4. So we already have that on the left-hand side, essentially, right? 6x minus 4, pretend that's there. 6x minus 4. Oh my goodness. But now we have to plug it in on this side. So this is equal to 2 times, not x anymore, this whole quantity goes out here over here. 6x minus 4. To the, don't forget, it's to the third power. So this answer, f of g of x, I know it's weird, I know it's difficult, it takes a while to get, is 2 times 6x minus 4 to the third power. At this point, I just want to stop there and just say that's the answer, right? That's all we need right there. You do not have to evaluate this any further. That's it. All right, for the last one here, for part C, it gets a little harder. Just maybe because it's weird to see f twice. So the first thing we're going to do is we're going to take f of x, and we're going to put in here what it's equal to. So we'll keep the f on the outside, right? And then go up to f of x. Probably just delete this stuff now. It's equal to 2x to the third. 2x to the third. Then we're going to apply the f function again. So we're going to take this whole thing, put it in for you see an x. So pretend you're taking this out, delete, and insert what's inside the parentheses here. So we're going to have 2 times whatever we have in this parentheses. 2x to the third raised to the third power. And that's all I want you to do. Like, that would be your answer, right? If you want to go further, I could do that quickly. You don't have to, but I could show it. You could raise everything inside here to the third power, which would be 2 to the third, right? This would be 8. And then you have power to power, that's just multiplication, x to the ninth, 3 times 3. And you put them together, you would get 16x to the ninth. And that's the same thing as what we had before. So, and that would be the answer to f of x. All right, so that's just like the basics of using a number, putting in a letter, or using the whole function, getting equations. So the difference between these two, AC and BD, is on the right-hand side, when you put in a number, you get out a number. On the left-hand side, when you plug in just x as your variable, you get out an equation with x as your variable. Completely different. Not really how you solve them necessarily, but they are very different answers. Okay, so that's how you do composition of functions. Now we can go back and try it with our word problem. So, back to example 2, and then I'll maybe do 3 and be done. Already going kind of long. Consider the situation example 1, but let's use the variable x for the price of the car. We're not using $33,000. So we have the following function. So see if this makes sense. The rebate, R of x, what we're calling it, is taking the amount the car costs, the $33,000 that we had, and just subtracting it by $2,000. Okay. The discount, if you're applying to the cost of the car, we'll call it D of x, is taking the percentage that you're going to pay for the car, 88%, because remember it was 12% off, times the amount the car costs, 0.88 times 33,000. So these are the two functions that we're using. So we're going to make an equation using composition of functions, using these two together, right? So we're going to write an equation for R of D of x. That is the final price if you take the discount first, because remember that's the inside part, doing discount first, and then the rebate. So we're going to do R of D of x. D of x we have defined for us as 0.88x. So this is now R of 0.88x. And then we're going to put 0.88x into the R function up here. And it's going to replace the x that's on this side. So we take that out and replace it with 0.88x. So now that becomes just 0.88x minus 2,000. So this would be an equation for any price of car where you take the discount of 88% first and then subtract 2,000. We just made an equation of this using composition of functions. Now the other way, write an equation for D of R of x. That would be if you take the rebate first and then the discount. All right, so rebate first, we're doing D of R of x. So it's D of, what's R of x? It's up here. Oh, delete that. Get rid of some of this. That would be x minus 2,000. All right. My pen would work. That'd be great. And then we look at the D function, discount function, and we see it's x minus 2,000. So that has to go into the 0.88x. We're taking this out, replacing with x minus 2,000. And since it's a multiplication here, we have to choose to use parentheses. So 0.88 times x minus 2,000, which you could then distribute if you wanted to. 0.88x. What's 0.88 times 2,000? That would be 1760. So hopefully you could see comparing these two answers. All right, let's go over this again. This would be rebate first, then discounts. This is R, rebate, then discount. That's the equation. Up here, you're doing discount, then rebate. If you compare the two equations, you could hopefully see that it is always better to do the discount and then the rebate, because these two numbers match completely, 0.88x on both of them, but then you're subtracting whatever you get here by 2,000, making the cost cheaper for you rather than 1760, which, by the way, is a difference of $240. So this next question looks kind of weird and hard. It's asking you, like, which one's better, right? Is it true that no matter what the car costs, that it's better to do the discount than the rebate? Is that's always going to be less than in price than the rebate than the discount? Will this always be better? And we just look at the equations? Yes, it would be. So it does not matter back here. Does it matter how much the car costs? No, it does not. It will always be better to choose, in this particular case, right, the discount then rebate. This is always a better choice. So we always want this one. All right, last little fill in the blank here. The function that maps x onto R of D of x is called composite. And is written you could do this too. Don't forget that other symbol. Looks like the word rod, but I'm trying to make a small circle here. It's R with a little small circle D, which is the composite D. Is it followed by R? I can't remember. The composite F followed by, followed by G. Okay. The composite D followed by R. I don't like that wording as much. This is obviously way better to use. Okay, last example, I believe. Yes. The next example we'll be doing in the huddle is actually plugging in numbers again. So like you're changing this to $50,000 car and just checking to see how much money it comes out to be, whether you do the discount and the rebate or the rebate and the discount. Last problem we're going to try is doing this again with the equations. So we have two new equations. We're going to calculate, this would be the composite G followed by F. So I'm going to rewrite that as F of G of X. Definitely don't like this notation, so we change it. So inside here, it'd be F of, what's G of X? So let's find it. It's this, 3x squared. There we go. Jeez. And then we go and find the F function. We're ready for that part. F is 5x minus 2. We're going to take the x out and replace it with 3x squared. So this becomes 5 times 3x squared, and then don't forget the minus 2 in the end. I understand these are really hard. It's going to take a while to get used to. So we're going to practice a bunch of them. And then I can just finish this. I can multiply these together to get 15x squared minus 2. That equals this, or this. F of G of X. Okay. Over here, we're going to flip them around. Just do it the opposite way. G of F of X. A good question is to say, is this going to be the same thing? Doesn't matter. Well, clearly back here, when we just switch the letters around, we didn't get the same answer. So we'll see what happens here. So G of F of X, that would be G of whatever F of X is, find it. It's this thing here, 5x minus 2. If I erase that part. So it's G of 5x minus 2. Then we plug everything here we see into the G function for x. So that gets plugged in right here. Take that x out. Delete. We have 3 times this whole thing, 5x minus 2 squared. And that would be your answer. Now, if you want to go further with this one, that would take some time, right? Because you have this being squared, which does not just go to everything. This means you have this. Whoops. You have 1 5x minus 2 times another one. And I would not expect us to do this. Like, I'm just trying to get to this answer here. And then you have to do this. 1, 2, 3, 4. Sorry. And then you have to multiply by 3. So it's a big process. Let's just get this. That's the goal right now. I just want that as an answer. And this is an answer, right? The rest of it you can do yourself. Team Huddle, there's 2 problems there. And then, 1, 2, 3, I guess. And there's 1 problem left in Team Mastery. So 1, 2, 3, 4 problems to do with some parts to it. And now I'll finish up 8.1, which I know is difficult, and we just need to practice a bunch of it using numbers and the equations.